So in a previous video, we looked at the Java array. We talked about arrays in general, whether they're in C++ or Java or some other language. And we said one of the issues that we sometimes run into with languages like Java and the array is that it is statically sized, meaning that once we create that array, it's fixed to that size. We can't grow it any larger, and we can't shrink it if we need to. So we're going to look at the solution to that Java gives us, which is a vector. Now, some languages allow for dynamically sized arrays. We're not going to worry about those. We're just looking at this in the aspect of it being with Java. So to do it, I've got a basic class set up with a static main that I can run, but I do need to import java.util. And the reason that we have to import java.util is this is where our vector is going to lie. So I'm going to say vector. And I'm going to create a vector of strings, and I'm just going to call this v, just for simplicity, equals new vector. Now, you may notice that after vector, I have angle brackets, and then I have my data type that I put for my angle brackets, in this case, a string. So this is a template style layout. We have to use these angle brackets to define what type of object are we storing. This provides some hints to Java and allows us to work with this vector. Remember, inside of Java, we have to use the same data type in a vector just like we would with an array. Now, we could possibly go in and put object and use the polymorphic nature of object-oriented languages, especially Java, to handle this, but we typically want to be focused on storing the same type of data. Mixing and matching data can be a little bit confusing in a lot of cases, especially with really complex applications. So we want to look at ways that we can simplify, and this is one way. Now, when I create this, I get an object, and I get some default amounts that are put in there. My constructor is overloaded, so I can put in, like, I want to start with X number of units, or I want to grow by so many units each time it goes through a growth cycle. Now, you might be asking, well, how does it store it dynamically? And if you know the basics of how an array works internally, you might be going, well, is it, copying things? Is it cloning things? The answer is we don't have to know. Remember, in a good object-oriented environment, that object and the way it's instantiated and the internal mechanisms of it are hidden from us. And so a vector is a great way to do it. Could we do a clone with a creation of a larger one? Yes. Could we maybe have an array of arrays? Yes. Could we do something entirely different? Yes. We only need to worry about, is it going to work for what we're going to do? So let's look at some basic examples here. So if I want to add an element to a vector, I can say v.add and give an a. So a is our string that we're adding in. Now, could I have put something else? You bet. I could have put a whole word. I might not have used string, and if I had created it with something else, I could have created with products, or I could have created with students, or orders, or anything else that I needed to do. But in our case, we're just using strings, so we're using a here. If I want to add another element, in this case, I've made another add statement, and I'm adding a lowercase a. It's a different string. I can say v.add and add another uppercase string. You might think, well, didn't I just add that element? Well, yes, I did, but this is treated as a separate string. So if I want to come in here, I can say for string s v system.out.println, I can say s. If I run this, it prints my capital A, my lowercase a, and then another capital A. It did it in the same order. So just like with arrays, the items that we add are added in order. Now, if you notice, I am specifically going in saying add. I can't give it an index and just put it in there. So let's delete that loop real quick. Because vector is a class, and all classes extend the object class, we know there's a toString. So we can say system.out.print You'll notice that the toString method, which gets automatically called when you pass an object in to the print line function, it says, ooh, let me go through this process. And it prints out square bracket and then my strings as I see them. So this is a very efficient way to print out the whole vector if I want to. Now, if I want to remove an element, I need to know the index of it. So I can say v.remove and specify an index. And when I do that, it's going to remove element 2. Remember, we start at index 0, so this is going to be our third or last element. If I come in and do my print line again, you'll see that it takes out my last element. So that's the easy way for me to go and do a remove. I have some other things that I can use. So v.contains, and then I can look for an element. We'll put this in a simple system.out.println. And you'll notice that it prints out a Boolean value. So this contains, it goes out there and checks, hey, does this object, in this case, this string, does it exist? Yes, it does. So we have the ability to check for contains, we have the ability to add elements, we have the ability to remove elements. What happens if I need to get an item at a specific index? Well, there's a get method. I can say v.get, and I'll specify index 0. This will print out the A. So if I need to use a standard for loop instead of that for each style loop that we looked at earlier, I can do this using the for loop, and the index is going to be using get. Now there is one downside to vectors I do want to warn you about, and that is vectors are a little bit slower than using an array. Arrays are very, very fast because of how they're stored internally in memory. But in a vector, because they're not necessarily stored in a logical, sequential area of memory, it means that we have to go out and find that information, and how that's done is going to be a little bit slower. Now, how much slower? Probably not a lot. If we're doing something where we have thousands of items we have to run through, then maybe it would be noticeable if we're doing some sort of intense calculation with this and we're going back and forth looking for information. On the other hand, if we have a standard desktop type of application, we only have a couple hundred elements that we're leading in and writing back and forth, the performance hit is going to be pretty minimal, especially given modern processors. So this is always something we have to look at is, what's my situation? Maybe it doesn't affect me, but it's going to affect you. Or maybe it's not going to affect you, but it's going to affect me in my application. So these are things we need to keep in mind. Now there's one other thing that I want to show you real quick. This is a real simple example of how we can use vectors, but I want to show you one more thing. Remember, we talked about vectors and how vectors are statically typed. Well, that's if we're using this template. I'm going to create vector v2 equals new vector. And notice that I am not specifying a type. So you will notice that this is giving me a little warning message. This is something here we need to look at. But I can come over here and say v2.add 3. This is going to add an integer. 3.14. This is going to be a double. And I'll even add pi. Pi being a string. So I have 3 different data types. Now, do notice that Visual Studio Code, in my case, is giving me warnings with this. But if I say system.out println v2 and run this code, you're going to notice that the vector is allowing me to use different data types mixed in. Now, as I mentioned earlier, I don't recommend this. I recommend keeping your data types the same. That way, when we pull this information out, it can be used and we know how to use it. Trying to kind of mix our data types, that's a great way to pretend like we're smart, pretend like we're being slick, and run into some serious errors when we're coding later on. So I don't recommend this, and this is why Java is giving us warnings. Like, yes, you can do this, but are you sure this is what you want to do? I prefer using the templating method, saying, hey, this is my data type, and being consistent. It reduces number of errors. So this is how we can use vectors inside of Java. They're dynamically sized and, in some cases, if you allow it, dynamically typed as well. I recommend only using dynamically sized if I'm willing to work with my limitations. Hope that helps you learn more about your data structures in Java. We've got more videos coming up.